Let me very briefly show you how mPyPl works. And to begin with, let's consider a very simple problem. I want to count natural numbers whose square is below 10. So normally to do it in Python, I would start with a list. Then I will use map to produce list of all squares. I would filter out those squares which are less than 10 and count the length of the resulting list. Of course, this is all can be written in just one list comprehension, but bear in mind it is just a syntax demonstration. So this is the purely Pythonic solution. Of course, this can be written also as one big statement, but this is not very convenient because the order of operations, mapping then filtering, is kind of reversed here. It's from right to left. So how can this be simplified using pipe syntax? We just need to say from pipe import star, and then we can write it in this clear way. We start with the list, then pipe it to the select operation. Select is the name of the operation which basically does map. We select squares, then we select those elements where x is less than 10, and we count the number of elements. And that's it. This is very clean and very easy syntax. But for real-world operations, pipelines, they are very convenient, but they can only operate on kind of one data stream. And in deep learning, we typically need to enhance the original data with with different operations. And to do that, we came out with mPyPl library. So suppose we want to produce those numbers, like we want to find numbers whose square is less than 10, but we need to find the numbers themselves. So how can this be written as pipes? We import our mPyPl library as MP. This is the traditional way to write it. Then we start with a number, and we say mp.asFieldX. In mPyPl library, what is flowing through the pipe is not just plain Python objects, but dictionaries with named fields. Those dictionaries are called mdicts, but more detail we'll provide at the end of this video. So basically, we name this sequence X. Then we add additional field to this sequence. We say apply. We take the field X and produce the field X squared. And we use this squaring function to do that. So now we have the sequence with two fields, X and X squared. We select only those whose square is less than 10. Then we, again, get only the field X from them and take, for example, the first or the last element. So this is how mPyPl syntax looks like. And you can find the library on GitHub, so github.com/schwarz/mPyPl. And there is also wiki and documentation there. And how does this look in the real world? This is an example taken from mPyPl wiki, which shows how to do image augmentation using Keras. So here what we do, we take the images from some kind of data stream. We take only two images, but random images, because we shuffle elements first. Then we actually load images from disk, apply random transformations, take 10 different transformations of those two images and show them in the GUI. So this is quite clear way to write it, because without mPyPl you would have to use a lot of auxiliary variables, and the code would become like more messy. More details and more demonstrations are provided at the end of this video. Feel free to have a look.